In this video, we are going to take a deep dive into the clash analysis icon of CATIA V5. Now specifically, this is going to be a static clash analysis, so assuming that we do not have any motion involved with this simulation. Before I get started, I do want to point out that I already have the SPA license on my machine, and that is short for the Space Analysis License. It is not mandatory to have this license to do like a quick clash analysis. However, having that license gives you just greater capability both in the clash analysis but also in the sectioning tool, which is, we'll get into later, a visual way of being able to physically see that clash a little bit better on the screen. So without further ado, let's go ahead and get started. For this demonstration, I will be using the following assembly file. It is a hitch assembly, which is used for towing capabilities on the back of a vehicle. My files have already been created and assembled using assembly constraints. It's important to note that nowhere on my screen do I see any red flags or any warnings that tell me that I have parts occupying the same space. So because we don't have that overt warning of any kind, it's important that you just follow up with a clash report. The first step in all of this is to, of course, find the icon to click on. You'll notice that I'm in the Assembly Design Workbench. The icon can exist in either the Assembly Design Workbench or the DMU Space Analysis Workbench, and it really wouldn't matter which of the workbenches that I'm in. It's still the same command, so I'm going to stay in the Assembly Design Workbench here. Here's my button. It's down at the bottom. It's in a toolbar called Space Analysis if you're in the Assembly Design Workbench. This is very traditional of what the box is going to look like when you begin. The first thing that you have to do is specify the name. If you don't see an area to input the name, that's just because you don't have that extra license. So you can give it a meaningful descriptive name. I'm just going to call mine here my hitch clash. And then you have to choose a type. There's 4 different options: the traditional, contact, and clash. The second one will add a minimum clearance distance, and anywhere that is violated, you'll now get an extra line item in the report. Authorized penetration is where you can allow a certain amount of clash to occur, and then any time that you have clash that exceeds a certain amount, it will still show up as a line item in the report. Then you can also create a very specific clash rule in the internal settings of CATIA. I'm going to do the clearance, contact, and clash, and the box to the side is where you would specify a minimum clearance distance. So I'm going to set that to 4 millimeters in my case. And then finally, you choose how you want CATIA to analyze the different items. Inside of one selection means maybe inside of a particular subassembly only, so only analyze the items of the subassembly. Selection against all would allow you to focus on like one individual item, so only the things specific to like a certain bracket would show up inside of the dialog box. Between all components is pretty straightforward. It's analyzing everything that you would have, and then between 2 selections would be specific to 2 items. I do want to analyze all of the parts that I have on the screen, so I'm going to leave it to between all components. When you are ready to run the report, it's kind of tricky. In the dialog box, there's an OK and an apply. A lot of my students are like, well, what's the difference? Which one do I click on? The difference is if you click OK, it just closes the box, but you don't see the actual result. What has happened is that it actually ran the report and then it closed it on you, so you can come back and see it. You just double click on it, it stores it in the tree. But if you want to see the actual report, you have to hit apply. So really, the one that you should be clicking on is the apply command. You saw it took a couple seconds for the report to actually run. And immediately you're going to see a little preview window that will pop up, and you can use this as a guide to kind of hone in on specifically where the area is of clash. Now there are some internal settings. I'm going to go ahead and jump through here, and I'll kind of bounce in and out of the dialog box a little bit just to show you how I like to set up my clash report. A lot of these are personal preference items, so if you don't want to make these changes, that's perfectly fine. Now my goal is to eventually fill out this entire list and then to save it somehow. Now you can either just simply click OK, it stores it to your tree, but you can also export it as a couple different types. When you click on the Export As button, the first thing you'll notice is that it does pop up with a little warning specifying that a clash repository has not been defined in the settings. This is just a default location that your machine is always going to assume whenever it goes to save any of these exported clash results. So I want to show you first where to go into your internal settings and specify this. It's not a super big deal if you don't specify a clash repository, because as soon as you click OK, it'll bring up a traditional Save As file selection box regardless. But let me hit cancel and jump into the internal options and show you where that's at. It's under Tools and Options, and there's technically two different locations where you can specify this. If you do not have the extra SPA license, then its location is going to be under Mechanical Design, Assembly Design, and it is the DMU Clash Process tab, and it's this option right here, Database Repository. If you do have the SPA license, then it's also located underneath of Digital Mockup, DMU Space Analysis, and then you have to go over, it is the tab called DMU Clash Process. It's the same exact thing, so if you enter it in one location, it basically carries over to the other one. So all you have to do is hit Browse. So I'm going to go onto my desktop and I'll just store it into this folder that I've labeled my Clash Reports. So now, if I come back into my Clash Report and rerun it, and then click on the Export As, it automatically defaults to that same location. Now I don't have much filled out here with my Clash report, so I'm just going to go ahead and hit cancel, but I will come back and export this when we're done at the end. Moving on to some more options that you can change, and again these are all personal preferences. Things that I like to modify are some of the visual changes inside of this little preview box. This is showing you our first contact constraint to look at. So it's a little chaotic, at least in my opinion, the way that it highlights all of like the products themselves that are having that particular issue instead of the surfaces. So you can see the yellow kind of highlighting extending all the way to the end of that bracket. If you would like to change this, make it a little bit easier to see, this is again an internal option. If you go into Tools and Options, this time I got to scroll back here to the left. We have some tabs, and the first tab that we're going to go to is the DMU Clash Detailed Computation. You'll see Contact and Clearance Result. You want to choose the surface, so it was set to triangle. So let's take a look at what the surface option does, and when I click OK and again go back into my Clash and reapply it, if you look at the difference on the screen, you can see that that yellow doesn't extend in those tessellated lines all the way to the back of the bracket anymore. Kind of focuses right around the area of contact. So for me personally, this is the method that I like to stick with. I think it looks a little bit better on the screen. There is also a third method called None, where essentially it just would not highlight anything yellow for contacted surfaces or anything green for minimum clearance distance. So completely up to you if you want to change that. A couple other things back into the internal Tools and Options. Under the numeric result, in the dialog box, when we click on each line item, there is a column that will change a value. Now for all contacts, the contacts will have a number value of 0, indicating that the surfaces are flush with each other. For clash, then it will tell you that penetration depth of the clash, or for your clearance line items, it'll show you the distance of minimum, basically clearance between the surfaces of the two items. If you want that number value to physically show up, you should have that turned on. If you want no number value to show up, you can turn it to none. And then lastly, you have the intersection volume. It is set to none by default. A couple other things that you can set it up to, and again these are all personal preferences, but kind of cool, these options, if you take a look at them. The first one is this voxel mode. So if I click OK and open our dialog box again, reapply this, you don't really notice any difference. Here it needs to be the clash where you see the difference. So if I click on the clash, I see that my first clash is occurring over here in this area between a bolt and our bracket. and it also doesn't show up the voxel in the preview window. You actually have to click to show the result window. But when you do click on the result window, let me zoom in here to this area, you'll see that I have this very kind of box-like shape that's popped up in the area directly surrounding that clash. Now the relative size of these boxes you can change with that number value that was in the internal options right next to it. But this creates like a physical block around the area of clash. And again, that happens when you physically turn on the result window. If I go back into the internal options, the last one is the Boolean. So the Boolean one is pretty interesting, and it's very similar to what I'm going to show you as a kind of alternative method in just a second. But when you click OK, and again rerun this, and once again you do have to click on the result window in order for this to show up and specify a clash. If I zoom in here, it creates essentially a Boolean body of the clash that's occurring. So it's a little hard to see, but I see a box, and that box would end up being a bounding box immediately surrounding the area of overlap. So those are a couple of visual internal options. And the rest of the box itself is the actual analysis. So with this, you're going to see a summary at the top. It tells me I have 45 a number of interferences, 9 of clashes, 32 of contacts, and 4 minimum clearance distance violations. That does mean on the bottom part of my result window I have 45 different line items that I can click on, and it will show me a preview. There are 3 different ways of visualizing the result. The first one is to list by conflict, where you have those 45 line items showing you the 2 products or the 2 items that have that issue. You can list by product, and this is exactly the same list. It's just, it does it. Anything that starts off with like the same product, it kind of groups them together. And then there's also a matrix view, which is for visual people like myself. We have basically a grid that's going to show these grid squares, which would be the combination of these 2 items. The symbols can either be touching in the corner, indicating that they're contacting. If they are overlapping, that's a clash. You also have a minimum clearance distance violation inside of this box. They have colors associated with them. Red means that it's basically been deemed a concern, a relevant concern. Yellow just means that they haven't clicked on it yet, and then you can also see green, which means that it's been deemed as not a concern. So I'm going to go back over to the list by conflict, and we can just kind of step through a few of these. I like to filter the list so that way you can first look at the contacts. The contacts are generally easy because most of the time you have inherent contacts that you want to maintain between the surfaces in this model. So the contacts will of course have a value of 0, and just notice that as I click on these, it is automatically switching the status column to relevant. It is programmed by default to do that. If you want to then deem it irrelevant, you actually have to click on the word one more time, and you can see that at this point it then switches all of the over to irrelevant. If you would like to add a comment, you can just click into the comment field, add in any comment box that you would need here. Now the minimum clearance distance, same thing. If you filter and say show me those, and you click on the individual line items, once again you're finding the area. It should be called out on your screen in green, but you just kind of take a look and you can see that we have surfaces that are not meeting our 4 mil minimum clearance distance. And again, every time you click on it, it goes to relevant. You can switch that. And then lastly, we have our physical clashes. This is the area of interference where parts are occupying the same space. Click on the line item. Again, it highlights the area in red and kind of draws your attention to that location. So let's take a look at this last clash that we have. So we do have an interference between my retaining pin and my pin. So what if I wanted to see what's happening a little bit better? Because a lot of times, unfortunately, these clashes occur in an area where you just can't physically see them very well. So we're now going to talk about our 2 visual tools or visual aids that we have to detecting these areas of clash. The first tool is the sectioning command, which is located right next to the clash command. When I click on the sectioning command, it does do a little split screen approach. I also have a secondary window that's popped up. That's the actual cross-section window. So let me resize this, make it a bit bigger here, and then I'm going to take my little Clash preview box and just scoot it out of the way slightly. So what I want to do first is tell my actual plane that defines the cutting location to go to a specific spot of my choosing. I'm going to do that first by coming over to the positioning tab and just hitting the home constraint. This is the default location for it to kind of populate initially, and from here it's just a matter of me tweaking where I want it to go to. I think I have a couple of planes that I can snap to this to. The planes are probably in the invisible space, so if I hop over, yep, I've got a couple of planes that I can snap this to. So let's click on the positioning by a reference item and then select on one of those planes. Yeah, so you can see how it put it right in the middle of my T-support for me. And then we can come back to my sectioning cut and then just kind of pull that through. And as we pull this through, I'm just trying to watch here to see if it eventually gets close to the area of clash. Now, the other thing that I like about this command, in the addition of the SPA license, you have this extra option called the clash detection. So now with that turned on, if I take my section cut through an area, as soon as it recognizes clash, there's a little circle that gets created, and then the area of clash is now going to be highlighted here in the red. So again, if I kind of zoom in and just glide my yellow cutting plane throughout this area, I can see the clash. If I go back to the positioning, I can maybe snap to a different face and again kind of glide through and then watch the clash here on this screen as I'm moving. So that's one way of visualizing this clash. And I'm going to cancel out of the sectioning command, which will take me back into the clash. I do want to show you a second way, but before I show you the second way, I'm going to go ahead and just export this. It's really easy. Click the button. Remember, we set up our default clash repository location. So at this point, you just choose your type. There's a couple different methods. The one that I really like is the XML file format, and the reason why I like this so much is because it will eventually take some pretty interesting screen captures for you. If I scroll all the way down to the bottom, that's the clash that I was just now looking at. I just want to show you that it took this screen capture for me without me having to like manually do any of it. So that's really nice if you save it as the XML file. It kind of does a little bit of that screen capture legwork for you. And lastly, let's make an actual body where we have the area of intersect visible. We're going to do this with the help of some Boolean operations. So I'm going to go ahead and just click OK to my clash box to close that down. And we're going to convert this product file into a single part file in order to do this. Now in the Assembly Design Workbench, all you have to do is be active on a product level, go up to Tools and go down to Generate Cat Part from Product. Just select on the product and click OK. This has generated a different part body for essentially every part within the assembly. It's now a different part body within one single part file. So the two items in question that are clashing right now, they're actually the retaining pin and the pin. So in the tree, that's the last two items. Just for clarity, I'm going to tell all the other part bodies to just be hidden. So again, that leaves me these last two bodies. I am next going to activate, changing my define in work object to one of the bodies, and then using the Boolean operations, I'm going to perform an intersect command, and basically that says, hey, show me only the area of intersect from one body to the next. So when I click OK and I zoom in, you can see that this is the entire area of clash, of overlap between these. So now that we have this body generated, I'm going to slide my screen so that way they're tiled side by side. And I want to basically take this body, place it into the product file. So in the product file, I'm going to right click and create a new part file. And then I'll choose node, so that way the origin is basically assumed to be the same origin as my product. So this new part is going to represent that body. It's really easy. I'm going to activate in this new part. I'm going to take that intersect body, I'm going to copy that, and then in this new part that I'm active on, I'm just going to perform a paste. So in my product file, I have this new body that represents the area of intersection. So to make this easier to see on my product screen, what I'm going to do is tell my two other files to be slightly see-through, and then I'm also going to tell the first part body to be a different color. So I'll tell that body to be red, and then I'll tell my two other part files that are clashing to be 75% opaque. And so this is another way, as you can see here, you're seeing the red shining through. So this is another way that you can create basically a visual body of the area of overlap using your Boolean operations.